Assalamualaikum warahmatullahi wabarakatuh. From the first, allow me to introduce myself. My name is Rindi Afriani. In this session, I will present about sintering temperature effect on photocatalytic activity of strontium titanate doping mangan. Introduction. The non-biodegradable dry residues can become a source of aesthetic pollution, eutrophication, and disturbance to aquatic life in the ecosystem. Methylene blue or MB dye is the colorant extensively used in leather, cotton industry where residue harms the environment. There are two techniques used in wastewater treatment. Those are adsorption technique and chemical coagulation. However, these techniques can lead to secondary pollution as the liquid dye transforms into a solid. Currently, heterogeneous photocatalytic procedures are favorable to eradicate water pollution, which degrades organic compounds to carbon dioxide, water, and less harmful materials. Among numerous photocatalytic materials, the metal oxide of perovskite type offer themselves as one of the remarkable photocatalytic materials. Strontium titanate or StO is well recognized as a promising photocatalytic materials. Next, recently, researchers have reported that doping StO with transition methods show improved visible light photocatalytic activities. Doping Mn is preferred due to its similar ionic radius with Te4+ and the same coordination number of sheets. Substitution of Te4+ by Mn4+ also narrows the band gap by lowering the conduction band minimum. First method used to synthesize StO. Among the available methods, the co-precipitation method has the advantage of good stoichiometry control and homogeneity. It can produce very small grain size particles in a relatively short time preparation. This study aimed to fabricate of strontium titanate doping mangan with variation in sintering temperature and investigate the effect of sintering temperature on the photocatalytic activity of strontium titanate doping mangan. And the following is preparation of strontium titanate doping mangan materials. And then the sample is characterized using XRD, FTIR, and photocatalytic activity by UV spectrophotometer. The profile confirmed the StO based on ICD number 8600178. The profile exhibits the peak smart start at 700 degrees Celsius, 800 degrees Celsius, and 900 degrees Celsius, according to ICD number 221437. These peaks correspond to the phase of strontium carbonate. The impurities intensity decline as the higher sintering temperature and vanishes at 1000 degrees Celsius. It reveals that the higher sintering temperature provides sufficient energy for the atomic of material to react completely. Next, the table 1, the lattice constant do not change significantly as the higher sintering temperatures. Commonly, sintering does not affect the crystal structure, one of which is indicated by the unchanged lattice constant. However, sintering temperatures affect the crystal size, which increases with the highest sintering temperature. Besides providing sufficient energy to react, High temperatures also increase atomic mobility, which will cut grain growth. This condition also results in better crystallinity. Next, figure 2, the spectra in the absorption band for 400 to 4000 centimeters minus 1. According to the reference, the absorption peak at 558.42 centimeters minus 1 is the SrTi0 strain, which indicates the formation of strontium titanate doping mangan. The absorption peak at 867.4 centimeters minus 1 and 3453.69 centimeters minus 1 are OHA strains, which are ascribed to the H2O molecule present in the sample. The OHA, SO, and CO strains represent the impurity of the sample, which decreases with increasing sintering temperature. It could be inferred that the FTIA results are in accordance with the XRD result. Figure 3. This result demonstrates that the fabricated strontium titanate doping mangan is capable of being a photocatalyst to degrade and dye. Overall, the intensity of the absorption peak decreases with increasing photocatalytic reaction time 6 to reaction time 1 to 6 hours under UV light irradiation. The variation of the sintering temperature does not appear to have a significant effect on the absorption peak position. Figure 4 display MB dyes degradation percentage. At sintering temperatures of 700 degrees Celsius, 900 degrees Celsius, and 1000 degrees Celsius, the degradation percentage of MB dye increases with the long irradiation time. Overall, the highest degradation percentage is shown at 1000 degrees Celsius for irradiation time of 6 hours. It might be due to the strontium titanate doping mangan powder at 1000 degrees Celsius does not contain any impurity so that it can deliver its best performance. Conclusion: the higher sintering temperature could vanish the impurity phases. The best sintering temperature and irradiation time for producing the strontium titanate doping mangan material was 1000 degrees Celsius and 6 hours, respectively, which could attain a degradation percentage of up to 66.63%. And that's all the presentation that I can present. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.